This question is from GATE 2021 Mechanical Engineering paper set 2, question number 32. A power transmission mechanism consists of a belt drive and a gear train as shown in the figure. Diameters of pulleys of belt drive and number of teeth T on the gears 2 to 7 are indicated in the figure. The speed and direction of rotation of gear 7 respectively are. Let's find out. So first relationship we will write for the belt drive. This is N. Let this be N1. So we can write the ratio N1 by N will be equal to D by D1 because we know that speed is inversely proportional to its diameter for a belt drive. And therefore we have this relationship. So we need to find out N1 here. N1 will be equal to D by D1, which is nothing but 150 by 250 into N is 2500. This gives us N1 as 1500 RPM. Now we see that the pulley in the belt drive which has speed N1 and this gear, outer gear 2, are both mounted on the same shaft, this one, and therefore we know that speed of gear 2 N2 will be equal to speed of this pulley N1, which is nothing but 1500 RPM. Now we'll write down the relationships between the speed and number of teeth on these gears in the gear train. So starting with second gear and third gear, we have N2 by N3 will be equal to minus T3 by T2 because these are externally meshed gears. We also have N3 will be equal to N4 because these two gears are mounted on the same shaft. Therefore their speed is equal. Second relationship we can write is between gear 4 and gear 5. So we can write N4 upon N5 will be equal to minus of T5 by T4. Again, these are externally meshing gears, so because of that we have this negative sign. Substituting N3 in place of N4, we will have N3 by N5 will be equal to minus T5 by T4. So we can multiply equation 1 to equation 2. This will cancel out N3 here because N3 by N3 will give us 1. What we are left with is N2 upon N5 is equal to minus T3 by T2 into minus T5 by T4. Keeping this relationship as it is, we also have relationship between gear 5 and gear 6. So we can write N5 by N6 is equal to minus of T6 by T5. These are also externally meshing. We also have the relationship N6 will be equal to N7. Gear 7 and 6 are mounted on the same shaft, we can see here. So replacing N6 with N7, we will have N5 upon N7 is equal to minus T6 by T5. Now multiplying this equation and this equation, because we can cancel out N5 from the numerator and denominator, and we will be left with N2 upon N7 is equal to minus minus is plus, so we have T3 upon T2 into T5 upon T4 into T6 upon T5, but there is a negative sign with this ratio, so we'll have a negative sign overall. We have this as minus T3 T6 upon T2 T4 because T5 by T5 is 1. So after rearranging this equation that we have finally got, we can find out N7. Let's find out. Rearranging this, will have N7 is equal to minus of T2 T4 upon T3 T6 into N2. N2 we found out is 1500. Substituting the values of T2, T4, T3 and T6 as they are given in the figure, we will have minus of 18 into 15 upon 44 into 36 into 1500. This gives us N7 to be minus 255.68 RPM. This negative sign indicates rotation in clockwise direction. So we can write N7 is 255.68 RPM clockwise. This is clockwise because when we have taken N as 2500 RPM, it was anti-clockwise and we took it as positive. So we have actually followed the sign convention, anti-clockwise positive. And therefore the answer we got is negative. It means the direction will be clockwise. Let's go back and mark this option 255.68 rpm clockwise. Our correct answer is option D. Speed and direction of rotation of gear 7 respectively are 255.68 rpm clockwise. To learn more about gear trains, you can refer to the NPTEL video Transmission Part 1. It's from the course Fundamentals of Automotive Systems. The course is taught by Professor C.S. Shankarram. He is from Department of Engineering Design of IIT Madras. I hope this solution helps you clear your doubt. Thank you.